Everything you see around you, from the water we drink to the stars in the night sky, started with just two simple ingredients: hydrogen and helium. These two elements were the very first building blocks of the universe, forged in the fiery aftermath of the Big Bang. Hi, and welcome to Stellar Studies, your window to the universe. In today's episode, we're diving into the incredible tale of how the universe's very first elements, hydrogen and helium, were born. These two simple elements became the foundation for everything we know and love, from the stars above to the life we cherish. Let's start the journey. Chapter 1. The universe is born. The Big Bang. It all began 13.8 billion years ago with a moment so profound and mysterious, it's simply called the Big Bang. In an instant, the universe sprang into existence, starting as an infinitesimally small, incredibly hot, and unimaginably dense point. Within a fraction of a second, less than a trillionth of a second, it began to expand faster than the speed of light in a process known as cosmic inflation. After the Big Bang, the universe was an unimaginably hot and dense sea of energy, trillions of degrees Celsius. For the first fraction of a second, it was so intense that particles, as we know them, simply couldn't exist. But as the universe expanded and cooled, something extraordinary began to happen. Chapter 2. The birth of protons and neutrons. About 1 microsecond after the Big Bang, the temperature dropped enough to allow quarks, the fundamental building blocks of matter, to form. These quarks came in different types, or flavors, like up quarks and down quarks. It was their interactions that set the stage for the birth of protons and neutrons, the first building blocks of atomic nuclei. Under the immense pressure and energy of the early universe, 3 quarks joined together to form protons, each made up of 2 up quarks and 1 down quark. Simultaneously, another trio of quarks, 2 downs and 1 up, formed neutrons. These particles were bound together by a powerful force known as the strong nuclear force, the glue that still holds atomic nuclei together today. But it wasn't just a peaceful process. Protons and neutrons were constantly created and destroyed in a chaotic dance of energy and matter, only as the universe cooled further. About 1 second after the Big Bang, did enough protons and neutrons survive to shape the future structure of matter. Chapter 3. Nucleosynthesis, forging hydrogen and helium. With the universe now just a few seconds old, the stage was set for the first alchemy of the cosmos, nucleosynthesis. As temperatures dropped below 1 billion degrees Celsius, protons and neutrons began to collide and stick together, forming the first atomic nuclei. But this process wasn't as simple as it sounds. Protons, with their positive electric charge, naturally repelled each other. Only the extreme energy of the early universe allowed them to overcome this repulsion long enough to fuse. And when they did, they formed deuterium, an isotope of hydrogen containing 1 proton and 1 neutron. Deuterium was the first stepping stone. From there, deuterium nuclei collided with more protons and neutrons, forming helium, the second lightest element in the universe. Some rare reactions even produced trace amounts of lithium and beryllium, but hydrogen and helium dominated this cosmic forge. However, time was not on nucleosynthesis's side. After about 20 minutes, the universe had expanded and cooled so much that the nuclear reactions effectively stopped. By then, around 75% of the universe's mass was locked into hydrogen, with helium making up the remaining 25%. Chapter 4. How did these nuclei become full-fledged atoms? After the chaotic firestorm of nucleosynthesis, the universe was still far from calm. The nuclei of hydrogen and helium had formed, but they weren't yet atoms. Why? Because electrons, those tiny, negatively charged particles, were still freely roaming through the universe. The intense heat and energy of the cosmos kept them from settling down and binding to nuclei. The universe needed time to cool. Fast forward to around 380,000 years after the Big Bang, when the temperature had dropped to a manageable 3,000 degrees Kelvin. At this point, something monumental happened. Electrons finally slowed down enough for the positively charged nuclei to grab hold of them, forming the first neutral atoms. This process, called recombination, marked a turning point in the universe's history. For the first time, light could travel freely across space without being constantly scattered by free electrons. This released a faint glow of radiation that we can still detect today, known as the cosmic microwave background, or CMB. Hydrogen, The simplest and most abundant element was now the dominant building block of the cosmos, with helium as a close second. These fully formed atoms began to gather in vast clouds, sowing the seeds for the formation of the first stars and galaxies. The universe, now calm and transparent, entered what scientists call the cosmic dark ages, a period of darkness before the first stars ignited. But within these clouds of hydrogen and helium lay the potential for everything we see today: the galaxies, the stars, and even life itself. And so, the simple hydrogen and helium atoms forged in the aftermath of the Big Bang were just the beginning. They would go on to fuel the spectacular next chapter of the universe's story, the birth of the first stars. Chapter 5. Why only hydrogen and helium? By now you might be wondering, why did the early universe produce only hydrogen and helium, with just trace amounts of other elements like lithium and beryllium? Why not carbon, oxygen, or the heavier elements that make up life and planets? The answer lies in three key factors: time, temperature, and stability. Let's start with time. Nucleosynthesis, the process of forming atomic nuclei, happened during a brief 20-minute window after the Big Bang. That's an incredibly short time frame to build the building blocks of matter. As the universe expanded and cooled rapidly, conditions for nuclear fusion ended before heavier elements could form. Next, temperature. Early on, the universe was unimaginably hot, perfect for fusing light elements like hydrogen and helium. But as it cooled, it lacked the energy needed to fuse heavier elements. The reactions simply couldn't overcome the powerful electromagnetic repulsion between nuclei. Finally, stability played a big role. Heavier elements require complex pathways and highly stable intermediate nuclei to form. For example, carbon requires 3 helium nuclei to fuse in a specific, delicate sequence, a process that only happens much later inside stars. In the chaotic, high-energy conditions of the early universe, such reactions weren't possible. This is why hydrogen, with its single proton, and helium, with its 2 protons and 2 neutrons, were the dominant products of Big Bang Nucleosynthesis. They were simple, stable, and easy to form under the conditions of the early universe. Chapter 6. The Legacy of Hydrogen and Helium. Today, billions of years after the Big Bang, the legacy of hydrogen and helium is written across the universe. These two simple elements, forged in the universe's infancy, remain the foundation of everything we see, touch, and are. Take hydrogen, for example. It's the most abundant element in the universe, making up about 74% of its normal matter. It serves as the primary fuel for stars, driving nuclear fusion deep within their cores. This process powers the stars' incredible light and heat, while forging heavier elements like carbon and oxygen, elements that make life possible. And helium? While it might seem like a quiet second-place contender, it plays a crucial role in stellar evolution. As hydrogen burns out, helium takes center stage, allowing stars to undergo new phases of fusion, creating even heavier elements like carbon, nitrogen, and iron. Without helium, stars wouldn't shine as brilliantly or live as long. But the legacy of hydrogen and helium goes beyond just stars. These elements are the architects of the universe's structure. Vast clouds of hydrogen and helium acted as cosmic scaffolding, coalescing into the first stars, which then clustered into galaxies. Without these building blocks, galaxies like our own Milky Way would never have formed. And let's not forget their role in life itself. Every breath we take contains traces of helium. Every drop of water is a combination of hydrogen and oxygen, from the simplest hydrogen atoms to the helium that makes stars shine. Their legacy lives within us too. Conclusion. And that's a wrap on today's journey through the origins of hydrogen and helium, the building blocks of our universe. These two simple elements laid the foundation for everything we see today, from the stars in the sky to the very atoms in your body. If you found this fascinating and want to dive deeper into the mysteries of the cosmos, be sure to hit that subscribe button and turn on notifications. Here on Stellar Studies, we're all about making space and astronomy easy to understand and exciting to explore. Got a burning question about the universe or a topic you'd love to see covered? Let us know in the comments below. Your curiosity could spark our next big video. And don't forget, sharing is caring. If you know someone who'd love to learn about the cosmos, share this video and spread the wonder of the universe far and wide. Until next time, keep looking up The universe is waiting to be explored, right here on Stellar Studies.